Of course, in the machining operation, you will require powers because you're using machine tools, right? So the power to perform machining can be computed by using PC equal to FCV. So PC is the cutting power, FC is cutting force, and V is the cutting speed. For the US customary unit, power in the traditional is expressed as horsepower. So you know that, like the aircon, you know that the PC, how much is the horsepower, right? So that's the same for the machine tool also. So in order to convert that one, you have to divide FCV that we calculate for the power divide by 33,000. So you will have the cutting horsepower. So as we know that each machine have their own efficiency, right? So usually for the gross power to operate the machine is PG, and HPG is given by PC that we calculate previously divide by the E, which is the mechanical efficiency of the machine tool. Okay, so typically for the machine it is around 90% if it is in a good condition. Okay, so for HPG, so HPC divide by the E. Okay, apart from that, it is very useful also to convert power into power per unit volume rate. So we call it as unit power PU or unit horsepower HPU. Okay, so how do you want to calculate the PU? PU is equal to PC divide by the material removal rate. So it's the same for the HPU also. Okay. Okay, so if you want to make it into the a complete equation, U or PU equal to PC over RMR or equal to FCV over VT naught W. So VT naught W is for the milling operation, but for turning you can use VFD. Okay. So unit for the specific energy are called uh, nanometer, Newton meter over mm cube or joule per mm cube. So now let's see the example on the specific energy. So for example, you are performing the machining operation by using the cutting speed with 100 meter per minute, and then the T node given is 0.5, W is 3.0 mm, and FC equal to 1557 Newton. So from this one, you will be able to calculate the PC. PC is FC times V, right? So F is already given and V also is already given. So you will be able to get the PC value in terms of Newton meter per minute. It is 155,000 with 700 Newton meter per minute. So if you convert it into joule per minute, it become like this. And then if it is convert to the watt, which is joule per second, it become 2595 joule per second. How to convert this one is divide by 60. So then you will be able to get the joule per second. So for specific energy, it is U or PU equal to PC divided by the RMR. So you just calculate the RMR as additional. So for this one, they calculate it become 150,000. So 155,700 divided by 100, 150,000. 150,000. So you'll get 1.038 Newton meter per minutes cube. Okay. For specific materials with specific brittle hardness, the value for specific energy is already given. So this one is based on the experiments by researcher and the technicians. So they come out with a table like this. Okay. So for example, carbon steel with the 150 around 150 to 200 Brinell hardness, it is 1.5. Or 240,000, or unit horsepower is 0.6. Okay, so that's the example. So for example, if you have let's say aluminium, so you can just go to aluminium, get the value 0.7 from the table, or horsepower is 0.25 or something like that. Okay, so usually in the calculation, if the material is given and the value for specific energy is not given, you can just go to the table. So now let's see the example here. In a turning operation on stainless steel, cutting speed equal to 150 meter per minute, feet equal to 0.25 mm per revolution, and depth of cut 7.5 mm. How much power will the lathe draw in performing this operation if its mechanical efficiency equal to 90%? So meaning that you want in this question, they want the gross. You have to understand, because they want how much power will the lathe draw in performing this operation if the mechanical efficiency is 90%. So since the E is given, so meaning they want the PG, right? So in order to get the PG equal to PC over E, right? Okay, so now we already have the efficiency. Okay, so we have to calculate the PC. So PC, how do you calculate the PC? If it is FCV, so is F is given inside here? No, right? So V is there, but FC is not given. So you will not be able to use this equation. So what are the other questions that have PC, and we have all the information that we want to calculate the PC. So here they already said use table 17.2 to obtain the appropriate specific energy value. So meaning that you can calculate PC by using the PU equal to PC over RMR. Remember? Okay, so then by this one, PC equal to PU time RMR. Okay, so now what we don't have here is PU. You can check inside the table, because this material is given, right? Stainless steel. You can refer back. So this one, the value is already given. U is equal 28 Newton meter over mm cube, or 2.8 joule per mm cube. So now the only things that you don't have is RMR, right? So RMR equal to VFD. So you just calculate this one. You have to convert it because it is 150 meter per minute. So you have to make sure the unit is the same for all. Let's say it is mm. So everything's supposed to be mm. So here they convert it to mm. So you'll get this value as the final RMR. So now, how do you get the PC? PC is 4688 divided by the PU. Not divide, times the PU. So you'll get this value as the PC. So then you convert, you put it inside here. So PC divided by the efficiency equal to 14.6 kilowatt. Okay, so that's how you solve the problem. So let's see some other problem also. So one of the foremen in a machine shop complained of a problem with the end operation in the turning section. It seemed the lathe has a tendency to slow down or stall in the middle of the cutting operation, indicating that the machine is under power. Okay, so under power, not enough power to run the machine. For the work material and condition of the cut. Without knowing any more about the problem, what action and changes can be made to mitigate this power problem? Okay, so it's already given that it is under power. It is not enough power for that kind of material or for the cutting condition. So what are if we want to see what is power? Power, cutting power equal to F V, right? So meaning that they have force and also the V. So this one is related to the power. So how to solve this equation? not equation, to solve this problem. So we have to tackle on this thing. So as previously I said, P cutting equal to F C V. So what are the things that relate relate to the power in term of the cutting? So it is the V, kan? The cutting speed. So what you have to do, if in order to reduce the PC use, so you can reduce the cutting speed, and also feed rate, and also depth of cut also, because this one is the one that give to the force. And then this is the third one, is the last chance lah, meaning that if you are not able to perform the machining process on that machine, so you can operate on other lathes with a higher power capability. But if you want to solve the problem by using the same machine, so what you can do is reduce cutting speed, reduce feed rate or depth of cut, and then you can also use the cutting fluid. So cutting fluid will give a better cutting, to make the cutting smoother, right? So meaning that it will reduce the force inside the machining process. So then the power can be reduced. Okay, you can also use a cutting tool that has a larger rake angle. Okay, so when it is larger rake angle, when they perform the operation, there will be less power on the cutting tool, and also the chip to come out. Okay, so that's why we use use the large rake angle cutting tool. So in the machining process, 90% of the heat will be converted into heat. So that's why if you can see in the machining process, usually is the environment for the machining will become hot. Okay, so this cause temperature to be very high at the tool chip. So between the tool, okay, so let's say the tool that machine and also the work material, this area is the most high in temperature. Okay, so it can goes up to 1000 degrees Celsius. The remaining energy of 2% is retained as elastic energy in the chip. So the chip that coming out from the machining also, there will be heat. So now you know that why when after the machining process we cannot touch the chip directly. Okay, so because why, there are still remaining temperature inside the chip. So what are the implication of the cutting temperature to the machining process? So what happen is, if the temperature is too high, it will reduce the tool life. Why? If the material for the cutting tool is metal, it can soften the area over here. So then it will cause the tool to break, or it can also make this part become softer. Okay, so then the implication will be it reduce the tool life. It can also produce hot chip that pose safety hazard to the machining operator, the machine operator, and also it can also cause inaccuracy in part dimension due to the thermal expansion of the work material. So due to that, Nathan Cook come up with the equation to predict at least the temperature rise at the tool chip interface. Okay, so the equation is like this one. Okay, so what are the component inside here? So U is the specific energy. Okay, specific energy of the material, and then V is the cutting speed. T naught is the chip thickness. Okay, so this is the constant volumetric specific heat of the work material, and K is the thermal diffusivity of work material. So these two value usually given, or you can check it from the table given. So experimental method also can be used to measure temperature in machining. So the most frequent technique will be tool chip thermocouple. Okay, so they can use the tool chip thermocouple. So can trigger use this method to determine the speed temperature relationship. So we come out with the equation like this. T P, which is the measured to chip interface temperature, time the Vm. M is the constant, usually is given based on the type of material or something. Okay, and K is the thermal disability of the work material. So then let's say, for example, you don't want the temperature to exceed certain temperature, so you can predict and get what is the value for the cutting speed that you can use during the operation, okay, using this equation. So that's the end for the part 1. We'll see in the next class. Thank you for listening. Assalamualaikum.